Hello, Python learners. So far, you have studied about the basics of Python, and in today's session, we'll enter into the advanced part. So, today we'll study about a very important library in Python, which is open source. It has immense importance and utilization in scientific and mathematical calculation. So, you might have guessed it right. It is Numpy. So, let's start. Numpy stands for numerical Python. You may wonder what makes NumPy so special and how it is able to handle such complex mathematical calculation. And the answer is NumPy is able to do it because it has a very specialized data type to handle such data, that is arrays. And at a first glance, it looks very similar to list, but there are differences between the two. Let's analyze them in our next slide. So far you may have studied about the built-in data types inside Python, like lists, dictionary, tuples, and a few more. But in NumPy, you have a very specialized data type, that is array. And how it is different from lists, and what in what terms is it similar? We will see both. So first the question is, what is an array? Array is a ordered collection. Ordered means it is indexed. By, and the default index is 0. Of each element is of same type, which means it is homogeneous. You cannot have multiple data type inside an array as it was used in list. So exactly, this is the difference between them. So you can say, you can define an array as an ordered collection between two square brackets, and at once it can hold only one kind of data type. You cannot have like here it is holding integers. If you write float, it can hold only float. You cannot mix integer with float or with strings or with any other data type. That is a primary difference between list and array. And why what so what happened in list is, you had multiple kind of data type at once. So you had strings, you can have a dictionary, you can have any other data types, I mean, like inside a list. And what it did was, for every element, you can see this, for every element, what are different what are the different information you have to store inside memory. Because at last what happens is, in these variables, whatever variable you define, all this has to be saved where? Inside memory. So obviously, for saving in memory, you have to save the data type information for each and every element. Apart from the value information, the for valuation, what it is, like value is 1 here, you also have to store the data type information for each and every element. And it this made it very slow for mathematical work. This Although this gives a lot amount of flexibility, and I can tell you, list was designed for a very generic purpose. Like it was like, you can say, a Swiss knife for all type of different kind of work. But for mathematics, you needed speed, you needed element wise operation. In in list, you cannot have an element wise operation, but an array do have that. So these are the features an array was built, because because you achieved speed of calculation inside it. You have very simpler memory allocation, because you don't need to save redundant this data type information for each and every element. And the memory allocation was made further simpler, due to the fact that the architecture of memory allocation in array is such that the data is stored in contiguous memory only, which means you need to save the pointer. Or you only need to save the first pointer, and remaining all data can be easily accessed, because though all the memory is contiguous. I'll show you a brief image of that. Okay, this. So in array, you just need these both are memory allocation. This is this is how it is done inside the list, and this is how it is done inside an array. You can see how much messy this data write and read operation can become inside a list, because you need to store different kind of data type information along with the values. But in arrays it is very simple. You just need to save the first pointer data, right, and all elements can easily be accessed or processed in an array. This is the basic architectural difference between list and array, and this is what has made major difference between them. So we'll move to the next slide, where we will learn about how we can create how can create array from list. Creation of arrays from list. Okay. Now we are going to see how can we create arrays from a lot of ways. And here we are going to execute the code in the Jupyter notebook. It is very similar to as any other coding editor, but the basic difference is that we can use text blocks into it. And it has a lot of other features we are going to see one by one afterwards. Right now we are going to concentrate how can we create array, and the first way to do it is using list. And now for do so, how can we do it? So the coding block starts with an import statement, and we need to import numpy, because we are going to use a numpy library. It is an external library, it's not an inbuilt library. That's why we need to import it every time we use numpy. And now next is we declare the variable and say we need to create an array from numpy library, and now we will declare the list. Whatever element we want to add inside it, it will convert it into an array. This list is now being converted into an array. So this is the first way to convert to create an array from list. So next is from a range function. So you may have heard about the range function in list. It what it does, the same thing is is this a range function. So for the same thing, same once we have imported the numpy array, we don't need to do it every time. And now we just need to say that we are going to use a range function, and a range function has three parameters. First one being the start index, and the second one being the end index but not including it, and the last element is the jump parameter. Jump parameter is help means, if you don't write anything, it will take a default one, and it will be continuous values from 1 to 99. But if you write 2 into it, it means that it will jump every alternate number, and you can see what we get from 135 is every alternate number is being taken till 99. So this is how to create an array from an arrange function of numpy, and we have seen it. It's very easy, fairly easy, and it gives only linear array. It gives a one dimensional array only. So it will see how can we reshape it into a two dimensional array or three dimensional array. It's very easy to do it. That there we so later onwards we will see how we can convert this into two dimensional, three dimensional, and or any n dimensional array. So at least we have first learned how to create it. Okay. Now the third way to create an array is using the zeros and ones function in NumPy. You can say if you want to create an array of zeros, then you can say np.zeros. The zero function is being used from the of NumPy array, and here we need to declare that size of zeros. If I want to say I need to create an array of 10 elements, just I need to say it will create an array of 10 elements which are all where all elements are zeros. You can see here. Okay, there are 10 zeros over here. If you want to increase it, if you want to have a different dimension, like if you want to create an array of 3 cross 3 in that 3 cross 3 array, means it has 3 rows and 3 columns. So okay, there is some difference because I have not closed it. Okay, now so you need to you need to specify the number of the shape of the array here. And if you write one number, it will be a linear array of 10 elements. But if you write the dimension if you write the shape of the array, then it will create zeros. It will create the zero array of that element, of that shape. It is 3 cross 8, it is 3 cross 3. And similarly is ones. You can create an array of ones where you just need to specify the shape inside it and you create an array of one. So even there are times where you need to create arrays, very large arrays, and just we want only zero array or one array. There are times when mathematics we need to create. So that is where we can use it. And from the line space, this function here also we can create an array by specifying np dot line space, which means there are you have to mention the space or the range of values, number of elements, and the range of values in between the elements. So first I will specify the from start element to the end element. See, I want to create an array from 1 to 10, and how many elements do I need to create? I need to create 50 elements. I need to create an array of 50 elements, and it should be between 1 to 10. This is how I write it. Okay. See, for 1 to 50, there it has 50 elements, and all are between 1 to 50. The last element, sorry, 1 to 10. I create an array of 50 elements, and all 50 elements should be between 1 to 10. The last element is 10, and the first element is 1. This is how I specify the range of values, and I tell how many values I need to create. It does it, and every element is equally spaced between each other. So this is how NumPy has a very strong features, very strong built-in, is has very strong library, strong modules, some modules, which helps it to create arrays from a lot of ways. So this is end of this session, and hope I'll have made it very clear what an array is, how it is different from list, how we can create array from a lot of ways. We have seen in the coding editor. Just we need to just write a few lines of code, and we can do all complex mathematical computation in using NumPy. I hope you must have enjoyed. Let's get keep watching my videos, and we will see in the next video where we do a lot of operations and see the attributes of NumPy. So thanks.